Hello everyone, my name is Raisa Sadinarendra from Group 3. So I, I will explain our group discussion presentation. The topic that we have is regarding an ultra low power smart headband for real-time epileptic seizure detection. So the chapter 1 is a journal overview. The introduction. The title of the selected journal is an ultra low power smart headband for real-time epileptic seizure detection. This journal was published in IEEE Journal of Translation Engineering and Health and Medicine in 2018 by Si Kailin and team from National Chao Tung University, Taiwan, in collaboration with Microsoft Research Asia. So as you can see from the picture that the headband. And next I will explain the headband. This journal is focused on wearable health monitoring technology, especially for epilepsy detection using EEG signals. The main topic is the creation of an ultra low power smart headband that can automatically and accurately detect epileptic seizure in real time. And the headband is continuously record EEG electric signal from the patient head, analyze them using a built-in seizure detection algorithm, and then send alerts via Bluetooth to a smartphone application. This app can notify family members or doctors and upload seizure data to the cloud for the further medical analysis. The purpose. The purpose of the research is to provide an alternative solution to traditional epilepsy monitoring methods that are often invasive, expensive, and require hospital equipment. By developing a compact and energy efficiency headband, the research aimed to first, continuously monitor the patient brain activity using EEG signals. Second, detect seizure automatically without the need for hospital supervision. The third one is alert family or medical staff immediately through a connected mobile app. The fourth one is store seizure data in the cloud for doctors to review letters. Ultimately, this innovation is designed to improve the quality of life of epilepsy patients, allowing them to be monitored safely and comfortably in real time. And so the next chapter will be explained by my friends.
This meeting is being recorded. This meeting is
Hello
being
everyone.
recorded.
Here I will explain about the hardware, how it's designed and how it connect with each other and how data move through the IoT system. This slide shows the system architecture of the smart headband. The device has a four different parts that work together, such as sensor, processor, Bluetooth module, and a battery. All these parts are linked together to collect the brain signal and process them and then send them to the cloud through app. These setup allow the system to monitor seizure in real time. Here you can see how the data move inside the system for the sensor pick up brain signal from the forehead, then the amplifier make the signal clear and stronger and then remove noise. The main chip checks the signal and detects seizure activity. The Bluetooth module sends the result to the smartphone and the finally app stores the data in the cloud so that doctor can see it anytime and remotely. So the complete data path goes from the brain, electrode, MCU, Bluetooth, app, cloud. These are the main hardware part in IoT system. The fabric electrode collects the brain signal from the forehead. The preamplifier makes the weak brain signal stronger and remove noise. The MCU, which is the main chip, acts as the brain of the system, checks the signal to find seizure. The Bluetooth module sends the result wirelessly to the smartphone app. The battery and flexible board give the power to the device and hold all parts together inside the head. Here it's all about the hardware used in the IoT. Next, my teammate will explain more about the hardware functions.
Hello everyone, I am Anmol Singh and today I am going to present on the topic ultra low power smart headband for real time appellants seizure detection. And now I am going to discuss the chapter 3, which is explanation of hardware components and their function for the project. So this section focuses on how each hardware part contributes to achieving real-time monitoring, low power consumption, and comfort for continuous use. So the smart headband is designed specifically for real-time EEG monitoring and seizure detection. It focuses on low power operation, variability and accuracy, all crucial for medical wearable. The system is made up of 7 key hardware blocks that include EEG sensor, signal conditioning unit, ADC, microcontroller, wireless module, power unit, and headband frame. Each component works together to capture brain signals, process them, detect seizure patterns, and send alerts to caregivers. So, the first stage handles signal acquisition and processing. The EEG sensors or electrodes capture the brain's electrical activity. They use dry or semi dry electrodes for comfort and operate within zero point 0.5 to 70 Hz frequency range, which is important for seizure detection. The signal conditioning unit amplifies these very weak EEG signals and filters out noise using high pass and low pass filters, ensuring the signal is clean. Then the analog to digital converter or the ADC converts the clean analog signal into digital data so the microcontroller can analyze them accurately in real time. The next stage focuses on control, communication, and support. The microcontrol unit or the MCU acts as the brain of the system. It runs the seizure detection algorithm, manages power, and processes the incoming EEG data. Common options include ARM, Cortex M4, or ESP32 chips. The wireless module, typically Bluetooth Low Energy, transmit data to a smartphone or monitoring system efficiently. The power unit supplies stable energy using a rechargeable battery with low dropout regulators for extended use. Finally, the headband frame, which holds all components in place. It is designed for comfort, flexibility, and long term wearability. Together, these modules create a reliable, low power, and portable system for continuous seizure detection. In summary, each hardware component, from the EEG sensor to the headband frame, plays a vital role in achieving accurate real time seizure detection while maintaining low power consuming and user comfort also. Thank you.
Good night, everyone. My name is Bismar Shauki Widodo, and for this presentation, I will continue to explain about the next chapter, which is the justification for component selection regarding, the IoT hardware based on the journal. And yeah, this is basically the component of the smart headband. And as for the explanation or justification or why it was the way it is, the first of all, we got the analog front end circuitry with preamplifier and three three fabric electrodes. Where the reason why it was the way it is because for one, the preamplifier is necessary to obtain a better quality signal. In addition, a high pass filter and active low pass filter are used to achieve suitable gain and bandwidth for EEG signal. As for the fabric electrode, it's mainly due to its conductive textile is made by from metal strand woven and textile with an excellent conductivity and soft performance. As for the epileptic seizure detection tech or SDT, it's we need it because it contains a mixed signal MCU and BLE chip where the former controls data flow and use SPI or signal peripheral interface to communicate with BLE transceiver as the EEG raw data and epileptic seizure detection result is transmitted to Bluetooth. And the other part is rechargeable lithium ion battery. It's important for the system because it has a high energy density, long cycle life, and fast efficient recharging process, which allow the system to continuously capture EEG signal and other operation regarding the signal detection result, which result up to 30 hours. It also had this another part of the system is biopotential measurement cable, which is very useful for the system operation since it was used to detect ion current change in tissues, including EEG signal to an amplifier and measuring instrument. And the last part that are pretty important is fabric headband, which is useful for the system since not only it was used to keep the wearable device on the subject's head tightly, but also allowed all the circuits component they are assembled on FPC to be integrated on, the fabric headband itself. Well, that's it today for our group. Thank you for listening. Forgive us if we made several mistakes. Good afternoon.